it might be useful for you to sort of see the eyes through which I'm looking at Frontline and the things that Frontline is doing, and sort of what I bring to that judgment of, is this a company that's worth me throwing my lot in with here for a while and doing some things with them and working with them? And the answer is, it's absolutely worth every second of my time, and I'm enjoying every bit of it, and it's an exciting company and a group of exciting people, and I'd like to just share a couple of my observations about that, and then I'll sit down and be quiet. About 2 years ago, I was minding my own business, doing some consulting and doing some entrepreneurial things, and a classmate of mine from the Air Force Academy called me and said, I got a guy you need to meet. And the guy he was referring to was Ryan Wood. And I said, okay, I meet interesting people all the time, I'll meet one more. And what I found was Ryan Wood was a lot more interesting than even my friend told me he was. Ryan is a sort of a today savant, engineer, creative kind of person that is the kind of person that moves industries and technologies forward today when they're already moving forward so fast that you really have to hustle to keep up. Ryan, if you don't know, graduated from Cal Poly in math, computer science, some other disciplines. Worked for a couple small companies you haven't heard of: Intel, Digital Equipment, Samsung, Toshiba, one of those companies that do those things. Yeah, I knew it was one of those. And then he got really interested in energy and in solving the energy problems that are really upon us and critically important to all of us in our futures. Worked with some turbine technologies that were right on the leading edge of getting the most out of wind power, for example, and some other things. But he's always had this fascination with things that fly and aeronautical things. And he has, through the years, made himself well versed in the areas of thermodynamics, fluid mechanics, and so forth. And so he got a little group together and they started building a flying machine, designing a flying machine. Now, lest you think this is a couple of guys in a garage, the first thing that Ryan said, well, you know, I've got this guy that's been designing this thing, is leading the design team. His name is Darryl Cummings. And I said, no, not the Darryl Cummings. Because during my years as a senior Air Force officer, and also during my years in Lockheed Martin, everybody knew Darryl Cummings. He ran the exploratory black world stuff, if you will, at the Phantom Works for Boeing. I could tell you some of the things that Darryl worked on, but I can't. But I know that, take my word for it, that he is a creative guy who did some astonishing things. So he kind of put this design together. Now, what is this? This is what started all of this. This is called V-Star. This is an unmanned aircraft system that does vertical takeoff and landing, and it can cruise at up to 400 knots. Why is that unique? Everybody that's talking about doing an unmanned aircraft system that's vertical takeoff and landing is doing one of two approaches. They're either taking a helicopter and making it an unmanned system, or they're doing something like an F-35 or a V-22 or some other system where you've got huge mechanical complicated things, rotating rotors or pivoting engine nozzles or doing some kind of weird thing so it can hover. This one doesn't have any of that. It's got a single lift fan at the center of mass, very simple design, and then this diamond box wing that he put on there. First, in my aeronautical engineering eye, I looked at that and I said, that thing can't fly, doesn't have enough wing. When you stop and realize that this thing doesn't have to take off and land, which is why airplanes need most of the wing that they have, is slow-speed flight. I mean, you transition from hovering flight to forward flight in this thing, and you get up around 250, 300 knots, that's plenty of wing for it to fly. So there's so much in this design that's creative, but I'm digressing, because the engine technologies are what we're really here for today, because that's where the immediate payoff is, and that's where the excitement is right now. So Ryan's looking at this thing. It's got two Rolls-Royce, formerly Allison, Model 250 turboshaft engines in it, which just happens to be this right here. So this thing has two of them. He's looking at it with his eye of the guy who's interested in efficiency and economy and fuel conservation, and oh, by the way, all of those things add up to give you greater mission capability, because they can go farther and go faster. He says, well, how do I do that? He looked at these engines with his eye toward what can you do with thermodynamics, what can you do with heat transfer, what can you do with fluid mechanics to make this engine more efficient. and he came up with two technologies, not just Ryan. He brought in some guys who are experts, leading experts in the field, and what he has come up with is a set of technologies that are some of the most exciting things that I've ever seen. Take this engine, which is ubiquitous. You will see the numbers. This engine is flying today on thousands and thousands of helicopters. If you were flying a helicopter and you had a mission where your ability to stay aloft is important, your ability to go a certain distance is important, or just your fuel costs are important to you, would you do something that would give you 40% more fuel economy? 40% better fuel economy. Think about that. That's huge. That is a game changer. And the reason that he's able to do that is not because he's got some exotic, high-risk new technology. It's because he's got a new way to apply technology that is very well known. There is no cosmic science in this. It is stuff that is just pure, simple thermodynamics. But what he's done is he's applied new materials and new manufacturing techniques to solve this problem. And you'll hear all about it in a minute. But I just wanted to share that from my perspective. As I saw this, which is kind of on the back burner right now because these technologies here are huge. And revenue from these technologies can easily bring this along or do anything else you want to do because the revenues are going to be significant. And you'll see that in a minute. But these technologies excited me so much. I said, man, I need to be part of this for the long term. This is exciting stuff. And so that's my story.